Hi and welcome to this tutorial. In this tutorial, I'm going to give you a brief introduction to the basic theories you need in order to play with the Arduino better. Okay, so the first thing we're going to talk about are energies. Well, there are many different kinds of energy out there, including heat, light, and electricity. Well, when we see the sun emits heat and light. When we look at the lights, well, the light emits light. As for electricity, it is what your computer runs on or what your tablet runs on. I think everyone's pretty familiar with this. Now, what the Arduino does, or what we want to do with Arduino, is to transfer back and forth these energy. Let's say I want to transfer energy from heat into electricity, or I may want to transfer energy from electricity to light. So it's the interaction between these, or the transfer between these energies. Now there are two kinds of transfer. The first kind are called the sensors. And what sensors do is to transfer energies that are non-electric into electricity. So let's say including from heat energy to electricity energy, from light energy to electricity. An example of this could be a light detector. What a light sensor does is it detects the light around it and transfer that energy into electricity. If you look at the other way around, from electricity into heat or light, we call them actuators. Well, there are lots of examples of what actuators are. The first most famous example could be your computer, because your computer runs on electricity, but you can only see the screen because it emits light for you to see. So we call this actuators. So if you're moving from this direction, we call it the sensors, but if you're moving the other direction, we call them actuators. Alright, the next thing I'm going to talk about are current, voltage, and resistance. Now this is a really complicated concept. In college, you might take like entire semester just to talk about current, voltage, and resistance. But we don't have the time here, so I'm going to give you a quick analogy and a quick way to understand it. Alright, now what I'm going to use here is the hill analogy. A lot of people actually like to talk about the river analogy, but both of them are the same. Just for simplicity, I'm going to use the hill analogy in this case. So right here, let's imagine you have a hill. On the top left corner, you have the high potential, which is the high ground. On the lower right-hand side, you have the plane, which is called the low potential. So you have high potential and low potential. The next thing is that there are rocks rolling down this hill. So these rocks are indicated by these green hexagons. So these are rocks rolling from high potential down all the way to the low potential. Always know that the rocks do not go to the opposite way. I mean, a rock does not run uphill. It always runs downhill. The next thing you're going to look are the obstacles. Well, no hill is exactly smooth, so we always have obstacles. Here I'm indicating the obstacles using those triangular-like things to indicate the obstacles. The next thing you have to know is height. Well, height is the difference between the high potential and low potential. So let's say that this hill is 400 meters tall. Or let's say this hill is 600 meters tall. So when I tell you the height, you have an idea what is the difference between the high potential and low potential. Alright, I think you got this analogy nailed. Let's look at the real thing. Here we're going to talk about current, voltage, and resistance. Same as before, we also have high potential and low potential. Rather than having rocks, now we have what's called current. So the currents are like the rocks that are rolling from high potential to low potential. In the river analogy, some people say that current is the current of the water flowing from a high potential to low potential. It doesn't really matter. All you have to know is that there are things flowing down from high potential to low potential and not the other way around. For obstacles, what we now name them as resistors. So resistor acts like an obstacle. So the more resistance you have, or the more resistors you have, the slower the current will flow because it will block it from flowing down. Now the difference between high potential and low potential is called voltage. If you remember from our previous lecture when we talked about the voltages on the Arduino board, remember that we said the highest voltage on the Arduino board is a 5 volts. Now that is the voltage of the high potential. And we said that the lowest voltage on the Arduino board is 0 volts. Now that is the voltage of the low potential. Deduct these two together, 5 minus 0, you get 5. And now 5 is the voltage that you get. So in this lecture, we talked about energy, how there are different kinds of energy. Examples are heat, light, and electricity. We also talk about sensors, right? It is energy flowing this way, and if the energy is flowing the other way, we call them actuators. We also talk about an analogy for current, voltage, and resistance, and we talk about the real thing too. Well, this is a really brief introduction to the theories. They are the actual theory. It will take really long time. Like I said, in college, it takes more than a semester to understand all of these things. But for right now, these are sufficient enough for you to play along with your Arduino. If there are any parts that you still don't understand, I suggest you to go back to the video and watch that again. Or the second choice is to take a look at the contents that are in the book. Contents in the book. There are really detailed descriptions in the books. If you still don't understand after you rewatch this video for many times and also reread the book many times, please leave it on the comment below. Leave your questions in the comments below, and I'll take a look at it. And if I find that most of the people have problems on a certain part, I'll make a tutorial video out of it so everyone can understand. Till then, that's all for today, and I'll see you in the next lecture.